So now we learn what the official definition of limit is. To say that the limit of f of x equals L as x approaches a means the following. It means that for all epsilon bigger than 0, this backwards 3 is the real number epsilon, a Greek letter, a variable. So for all epsilon greater than 0, there's a delta greater than 0. This is the Greek letter delta. So for all epsilon greater than 0, there's a delta greater than 0, so that if the absolute value of x minus a is between 0 and delta, then the absolute value of f of x minus L is less than epsilon. When you say it like that, I think it's really hard to see how this has any relationship to what a more intuitive description of this limit statement might be. I mean, what's this trying to get at? It's trying to say f of x is as close as I want to L by making x sufficiently close to a. So how to reconcile those two perspectives, right? How does this have anything to do with things being close? The key, take a look at this absolute value of a difference. Right? The absolute value of x minus a is the distance between x and a. So to say that the distance between x and a is between 0 and delta is to say that x is within delta of a. Right? The distance from x to a is less than delta. And to say that the distance between x and a is bigger than 0 is just to say that the distance between x and a isn't 0, right? X isn't a. So I can rewrite that maybe in a little bit easier way. So instead of saying that, it's the same thing to say if x is not equal to a, so the absolute value of x minus a isn't 0, and x is within delta of a. So the distance between x and a is delta. And I can do the same thing to this absolute value of a difference, right? The absolute value of f of x minus L, that's the distance between f of x and L. And to say that the distance between f of x and L is less than epsilon, well, that just means that f of x is within epsilon of L. So I'll rewrite that as that. Here we go. Then f of x is within epsilon of L. So I think when you write it like this, it makes a little bit more sense. Right? To say that the limit of f of x equals L as x approaches a means that for all numbers epsilon is measuring how close I want f of x to L. Then there's some corresponding number delta, which is how close x has to be to a, so that whenever x is that close, delta within delta of a, then f of x is really within epsilon of L. And to say that the limit of f of x equals L means that no matter which epsilon I choose, there's some corresponding delta, so that whenever x is within delta of a, then f of x is within epsilon of L. Now, how this actually gets played out in more concrete situations can be kind of complicated, but this is really the official definition of what it means to say that the limit of f of x equals L as x goes to a. And we're going to be trying to unpack this definition to see what it might mean in some specific cases.